Hello everyone. Today we're going to be looking at Unit 4, Lesson 6, Trapezoids and Kites. We're actually going to be splitting this unit up into 2 different days. So we're going to start off with day 1. So we have a lot of vocabulary here. This is most of the vocabulary from the unit. So look back at your vocabulary sheet for the definition of each of these words. And then we have some information here. So the first 2 pages of the notes is just all dedicated to information about trapezoids, that trapezoids are quadrilaterals with exactly one pair of opposite sides, talking about bases of trapezoids, legs of trapezoids, a base angle of a trapezoid. Then we get into some theorems about trapezoids. So we have theorem 2.1, theorem 2.2, theorem 2.3, and theorem 2.4, all dealing with trapezoids and trapezoid mid-segment theorem. Then the last 2 theorems are dealing with kites, and we're going to get more into kites on day 2, but day 1 is going to be mostly focused on trapezoids. So let's go ahead and let's take a look at our first example. So example 1, using the properties of trapezoids. So the body of a guitar shown is a trapezoidal prism. The front face of the guitar is an isosceles trapezoid. AB equals 3x minus 2, CD equals 3x plus 3, and AD equals 4x plus 5. And lastly, we have BC equaling 5x minus 6. We want to prove that x equals 11. So we're going to start off with our given statement. So number 1 is going to be our given statement. And our given statement is that ABCD is an isosceles trapezoid. Again, the reason for this is given. This is the information that we start off with. Now we want to start working through and proving this. So first off, what do we know by definition of trapezoids? So we know from definition of trapezoids that line segment AD is going to be congruent to line segment BC. So again, this is definition of isosceles trapezoids. Next up, well, continuing along with that, if they're congruent, that means they're going to be equal to each other. AD equals BC. And this is just definitions of congruent segments. Segments. So if the segments are congruent, that means they're equal to each other. Well, we know what AD is, and we know what BC is. So we said that AD is 4x plus 5. And we know that BC is 5x minus 6. Since we know that, that's just substitution. So we just substituted in the values that we were given at the beginning. 5. Well, now I'm going to start solving this out. I want to get x on one side. So I'm going to subtract 4x from both sides. When I do that, that leaves me with 5 equals x minus 6. And the reason for this is the subtraction property of equality. Subtraction property of equality. Now I'm going to add 6 to both sides. So when I add 6 to both sides, that gives me 11 equals x. And this is the addition property of equality. If you want, you could flip the order of it and say that x equals 11 by the symmetric property of equality, but we can leave it as this, and we have what we wanted to prove that x equals 11. So we've proven that out. Let's take a look at example 2. So example 2 is we're going to deal with isosceles triangles and a graph. So it gives us the coordinates and it says graph it out. Well, I'm going to give you the graph already. So here's the graph. So here is the graph. So I graphed out all the points. Now what do I want to do? I want to determine if this is an isosceles triangle or not. How am I going to do that? I'm going to start with the slopes and determining from the slopes if it's an isosceles triangle or not. So let's start off with the slopes. From the slopes, I'm going to use these coordinates here. I'm going to pull the coordinates from there. I'm not going to list off what are my x1s and my y2s. I'm kind of expecting you to know which ones those are from this. Q is going to be my 1s, R is going to be my 2s, and I'm just going to subtract them out. So I have 8 minus negative 4 over 0 minus 8. Negative 8. This is going to give me 12 over 8, which is known as 3 over 2. ST. So this is going to give me negative 10 minus 8 over negative 6 minus 6. Negative 10 minus 8 is negative 18. 6 minus 6 is negative 12. That's going to give me 3 halves. So 3 halves means we have parallel lines. All right, so far so good. Keep going. Next up, let's take a look at QT. We did QR, now we're going to do QT. So we want to show that these two, see if these two are parallel. And if we look at it, they're not, but we're going to show through math because sometimes looks can be deceiving. Negative 10 minus negative 4 over negative 6 minus negative 8. So that's going to give me negative 6 over 2 or negative 3. Lastly, RS, that's 8 minus 8 over 6 minus 0. 8 minus 8 is 0. 6 minus 0 is 6. So that's going to be 0. So these are not parallel. These are parallel. So that means trapezoid. If these two were parallel and these two were parallel, then we'd have a parallelogram and maybe even a rectangle. But because these two are not parallel, that means we got a trapezoid. Now let's deal with the leg length and see what we got here. If the leg length is the same, then we're going to have an isosceles trapezoid. If it's not, then we don't have an isosceles trapezoid. So leg length. Length. So that's going to be dealing with our distance formula. So we're going to have to do some square rooting. QT, because we're going to do our 2 legs, equals square root of negative 6 minus negative 8 squared plus negative 10 minus negative 4 squared. What does that give you? That gives you negative 6 plus 8, so that's going to give you 2 squared, Negative 10 plus 4 is going to give you negative 6 squared, which is going to give you 4 plus 36, so that's going to be 40. RS equals the square root of 6 minus 0 squared plus 8 minus 8 squared, which is going to give us the square root of 6 squared plus 0 squared, which is the square root of 36, or 6. Not the same. QT does not equal RS, so not isosceles. Again, we've first checked the slope to see how that worked out. The top and bottom need to be parallel, the sides not parallel. Then we check the leg length. If the leg length had been the same, we would have an isosceles, but they're not, so we don't have an isosceles. So now we're going to use mid-segment of trapezoid. So this is dealing with the theorem. So look back at theorem 2.24. So by the theorem, we know that UR, this middle point right here, is equal to 1/2 of this top part plus this bottom part right here. Again, this is theorem 2.24. So we're going to use that to help us out. So we want to find UR, which is that mid-segment. So that's going to equal 1/2 the sum of the top, PQ, plus the sum of the bottom, summing those two together, PQ plus TS. We know what PQ is, that's 11, TS is 18. So UR is going to equal 1/2, 11 plus 18. That's going to give me 29. So UR equals 14.5. Again, this is based off theorem 2.24. Now let's take a look at example 4. This time we have the mid-segment length, but we don't have one of the other lengths. So we're going to use that mid-segment theorem again, theorem 2.24, to help us out. So Rn equals 1/2 the sum of Lm plus QP. So Lm is going to be x. So this is going to give me 24 equals 1/2 x plus 16.7. All I did was look at my figure, plug in the values that I had. I want to get rid of this 1/2, so I'm going to multiply both sides by 2. So this gives me 48 equals x plus 16.7. Then I'm going to subtract 16.7 from both sides. So minus 16.7 minus 16.7. I get x equaling 31.3. So that means the length of LM is going to be 31.3. Let's take a look at the last example that we're going to do for today. Hold on to these notes because we're going to come back to them for day 2. So the last one that we're going to deal with today is example 5. In trapezoid ABCD, AD is parallel to BC. So it tells us right off the bat that AD is parallel to BC. So this is parallel to this. Find the endpoints of the mid-segment. So we want to find midpoints here. So we're going to start off with AB. So it's going to give me 0 plus 18 divide by 2, and then 8 plus 8 over 2. 0 plus 18 is 18. 18 divided by 2 is 9. 8 plus 8 is 16. 16 divided by 2 is 8. So the midpoint of this segment is 9, 8. And then the other side, DC, is going to be 1 plus 20 over 2. And then 4 plus 0 over 2. 1 plus 20 is 21. So it's going to give me 10.5. And then 4 plus 0 is 4. 4 divided by 2 is 2. So here's where we're going to stop for today. We're going to finish up the rest of the examples on day 2. So review through examples 1 through 5. Review through all the theorems that we've covered so far. So that's theorem 2.21 through 2.24.